Move to the final lecture of the day, which focuses on an area that connects health, sustainability, and food security, natural sweeteners, food security aspects, sustainability, and health impacts. This session will explore how natural sweeteners can serve as sustainable and healthier alternatives, contributing to improved public health and balanced nutrition while reducing our reliance on refined sugars. To deliver this insightful lecture, we once again have with us Dr. Antonio Rapso, whose previous sessions have been truly enriching and engaging. I now invite Dr. Antonio Rapso to take the stage and share his valuable insights with us. Over to you, sir.
Good afternoon. I hope you are not too tired for this last session of our 7-day, our GIAN course. And in this session, we will continue the discussion, our discussion about the natural sweeteners, this time more focused on the food security aspects, sustainability and health impacts. We have already another session more focused on the relevance of the food naturals for the consumers of these components. So, and now we will start to say that the natural sweeteners production must remain safe with no adverse environmental consequences. This is one of the major goals when we talk about a new ingredient, a new element that we want to introduce in a diet, when you want to stimulate its consumption. We have to make sure that that component, that food product is not harmful for the health of the population. So, natural sweeteners must be safe and, of course, no harmful also to the environment. So, it is presently necessary to guarantee that our food system doesn't pose any health problems to consumers and our planet. We must have this perspective. Regarding the production of safe and friendly natural sweeteners, I will highlight some examples of natural sweeteners that have been used in these last years, last times, especially in my context of Europe, but I believe also not only in Europe, also worldwide. Then I will also ask you about your knowledge and your trends of consumption of these particular sweeteners or even others you have here. First, I would like to highlight the erythritol. This is a natural sweetener, and the industrial production of erythritol has gained prominence with the rapid development of electrochemical processes. So during these processes, or this process, the erythritols and the erythritol are produced by the electrolytic decarboxylation of arabinoic and ribonic acid. These substrates are the substrates for the reaction and are obtained by the carboxylation of the sugars with six carbons. Oh, it's not. No, I think yes. It's fine. However, a more natural method involves the biotechnology process, which results in higher yields from fermenting a sugar source. So, erythritol derives from fermentation processes conducted mostly by fungi or other synthesized lactic acid bacteria. To produce this erythritol, the common pathways among yeast-like fungi genera include these that are mentioned here: the Trigonopsis, Candida, Pichia, Moniliella, Yaria, Pseudosima, Trichoposonoides, Arabinidium, and Trichoderma. This is the main genre of fungi that common pathways in order to produce this natural sweetener. Regarding the industrial production, proposes that this specific species of Yara lipolytica, Moniliella pollinis, and Trichoponoides meganicis are reported as the most effective amongst all we have mentioned before. So one main part of the production of this process involves the separation and purification steps. Once they are very crucial when the erythritol is used and is taken as a food additive with the function of getting our foods sweetened. A patent describes that to recover this erythritol from the culture medium, separation from fermenting microorganisms is a requirement. So it is followed by an ion change chromatography and crystallization. Moreover, the chromatographic separation step was subject to activated carbon treatment to recover this fraction of erythritol. And as we can see, it has this similar, let's see, in the right corner of the slide we can see it is aspect we can only by view we can finding similar to other sweeteners, to other sugars, and it can be used in that form to give some sweetened power to our foods. Another one, it is tagatose, another natural sweetener, and the biotechnological tagatose production, it is mainly by enzymatic isomerization that is a preferred alternative to chemical processes. And for the biological D-tagatose manufacturing, there are several biocatalyst sources that can be resorted. For example, the L-arabinose isomerase that we can abbreviate by L. AI, which can catalyze the conversion of this D-galactose into D-tagatose and converting also L-arabinose into L-ribulose. This is regarding and due to the similar configurations of their substrates. Yet the biological D-tagatose production is not very common and is limited, and given the lower bioconversion efficiency of this LIA, a metal ion requirement, and the poor thermostability and low affinity of this enzyme for the D-galactose. It has thus been suggested that applying the protein engineering and genomic tools may enhance this bioconversion efficiency for the tagatose production by amending the functional properties of L-arabinose. So, applying high throughput screening for a selection method helps to evaluate individual protein variants and hence increase the possibility of screening specific mutants with greater catalytic activity. During this D-tagatose production, the safety problem caused by the enzyme or cells have not generally recognized as safe, also called as glass hosts, can be overcome by transferring the gene of L-arabinose isomerase to the generally recognized as safe hosts like C-glutamin and Coronium bacterium, among genus, and this Bacillus megatherium. Ultimately, more research needs to be conducted to explore new sources of biocatalytics from these generally recognized as food microorganisms apart from the enzyme secretion and expression in the food grade microbial host. This is very important when we are talking about all of these, we can say new natural sweeteners that people are more not so accustomed to include them in their diet, because it is important to research and to assure that no harmful is posed in question regarding the health of the consumers, and a lot of research is needed to do also regarding this. Here another, and perhaps the most well recognized between all of us, the stevia glycosides. And these stevia glycosides have been used, I think, also here, also all over the world, have been widely used as a sugar kind of replacement, and more well accepted in one places, in one countries, from one populations, not so well in others. but several studies have been conducted and published in the last years on this. So, the raw materials employed in the process of producing manufacturing these stevia glycosides preparations are crushed leaves from the perennial shrub Stevia rebaudiana of the family Asteraceae. And what does these studies indicate? The studies indicate that several alcohols and ion exchange resins using this during manufacture process and extracting glycosides from stevia leaves involves thermal extraction and maceration. This is how we can produce the sweetener. And both the quality and yield of the products that are extracted from this stevia plant can increase by following techniques like supercritical fluids, also ultrasonic waves and microwaving. Besides, the multi-stage membrane process, which has been developed to concentrate these glycoside sweeteners, is also mentioned and highlighted with the bitter tasting components from the sweetener concentrate being washed down during the nanofiltration. And sometimes when this bitter, a kind of bitter flavor, bitter taste at the end, and people can identify some different flavor, a different taste when adding this final product to their foods. And this can be in some way one reason of it is not so well accepted. This can happen also with other cases of other sweeteners, very common when they extracted from plants. The convention extraction process described in the studies often follows similar methodology, whereby stevia leaves are extracted with hot water and alcohols. In some cases, the leaves are pre-treated with non-polar solvents, and to eliminate this is to eliminate fats, lipids, essential oils, and chlorophyll and other non-polar substances. With this pretreatment, the extracts are purified by precipitation with either salt or alkaline solutions, and then finally concentrated and redissolved in methanol for the crystallization of the glycosides. Another natural sweetener that I would like to discuss is the glycyrrhizin. The glycyrrhizin is also extracted from plants, and the methods followed to prepare this glycyrrhizic acid from the licorice roots have been investigated by several researchers in the last few years. And what is reported in the literature that the number of procedures as regards solvent extraction by various organic solvents, purification by ion exchange and polymeric resins, chromatography separation, sorption, foam separation, supercritical fluid extraction. So all these methods, the microwave assisted extraction, all these methods can be used to make the extraction of this glyceric acid from the plants, from the roots, the licorice roots of the plants. And most of this existing process that function to extract and purify the sweet ingredients from the licorice roots, that is what we want, involve several steps and large quantities of solvents and chemicals. So, extracting this glyceric acid from the roots includes extraction with hot water and ambient pressure in the presence of a number of additives, chemical additives such as alkalis as well, mineral acids, ethyl alcohol like aqueous ammonia, methanol, ethanol, which are the most well accepted technologies at nowadays, so at the current knowledge. And the primary aqueous extracts from the licorice roots contain this licorice acid and, of course, many other substances that are soluble in water, in aqueous medium. So, which are then subjected to further process with the main goal of obtaining a more purified product. So, this pure glyceric acid is also prepared from these roots using alcohol as the extraction solvent and in an ultrasonic device followed by purification. That is another option, of course, with different costs. And we can say that the conventional solvent extraction technique followed to extract this glyceric acid from the licorice offers several disadvantages, namely consider the solvent requirements that you need to add to make this extraction, and the extraction time can be also quite long, lower yields and higher extraction temperature. So all this requires developing an effective economic extraction method. And the purification procedure involves the acidification of the extract by the addition of some acids, and of course this can we can have some drawbacks related to it. The ultrasound assisted extraction has shown that the extraction rate rises due to the cavitation, because the developed cavity grows in size and then abruptly collapses with the release of energy at enormous rate, which thus increases the local temperature and pressure. Therefore, greater solvent penetration in cellular materials take place, which improve the cell content release in a bulk medium. Another one, the thaumatin, perhaps better known than glyceric acid or glycyrrhizin, but not so well known, I think, that, for example, the stevia glucosides. And this thaumatin production process can be strongly affected depending on the quality and availability of the source materials. In order to achieve a stable protein production that meets its demand, a series of studies were conducted involving these tomatin productions with genetically engineered microorganisms and transgenic plants. Although using a plant system offers some advantage over macro systems in terms of its scalability, safety, and economy, they still lack some benefits that can be obtained from macro hosts, such as the possibility of controlling growth conditions and product consistencies from batch to batch. The biochemical production methods have been considered for this production, because this protein is normally too expensive, and the recommended DNA technology be applied to produce sweet proteins in host microorganisms. And the most promising host known is this yeast, Pichia pastoris, that has a tight regulated methanol-induced promoter that well controls recombinant protein production. And despite thaumatin have been studied for a long time and for several groups of investigation, in the last 30 years there is still much to do, especially regarding the production to be considered cost effectively, and we can say it is can be considered a very interesting option, and to stimulate their daily use by the populations. Some other natural sweeteners that we can find in our lands, maybe, and perhaps more well known. Though you have here some sweeteners that have been described as ever friendly regarding their production methods, and that are becoming very popular worldwide. And these food ingredients can be considered also for health conscious consumers. And I would like then, of course, to see if you agree with this. If you have some other sweeteners, for sure you have in your country, in the regions where you live. But I would like to also mention these five. One is the honey, the raw honey. I believe all of you know, one of the oldest natural sweeteners. This honey is a sweetener than sugar, and is the only sweetener obtained from an animal source, in this case insect bees, and is a sugar secretion that is deposited in the honeycombs by bees, the species Apis mellifera, also indica, the well-known rock pea, among other species of these genes. We have the blackstrap novices, the byproduct from raw sugar refinery or a sugar cane factory, that it is thick, dark, viscous liquid that is left after the final sugar crystallization stage, from which no more sugar can be crystallized and economically used by usual methods. You have the maple syrup, we have talked about it, that is made from the sap exuded from the stems of the genus Acer. Usually in spring, it is particular from this season of the year. The sap primarily contains water and sucrose with varying amounts of amino and organic acids and phenolic substance, which is concentrated by heating to produce a wide range of flavor compounds. Then we have also the coconut sugar, very used in some particular countries, I would say, especially in the African country, in the African continent. It is locally produced from the fluent sap of the coconut tree and the coconut palm tree blossom, and the juice collectors climb the palm trees and cut off and open inflorescences with staples, and the escaping sap is then collected in bamboo or plastic containers for 8 to 12 hours, and the lime is sometimes added to prevent sap from fermenting. Of course, this has different costs. We can all imagine different production costs, for example, when comparison to the sugar cane or white sugar. We are more accustomed, and if we study a little bit or learn a little bit about the production methods for these alternatives, we can see the justification why when they arrive to the final consumer, the price is. Such as a low concentration of stevia glycosides with a small amount of organic sugar cane. Similar a combination of sweetening solutions that also can be used. And it will also depends on the geographical localization of where we are and the local products. This is when we talk about sustainability, this is very important because, for example, perhaps we can have access to all of these alternatives in our place, but some of them are coming from very far, and you can also see the differences of price, the difficulty of their accessibility, and perhaps other alternatives are more present, are more common, and the prices are even lower. So you have to see what can be the best alternative in our specific case. So consumers, of course, are eager to purchase products with natural ingredients. We have already talked about this and the relevance that all of us and all the consumers give to this naturalness of all the products they are buying. Clean labels, preferably with further functional properties. We have already talked about this and the importance of these functional properties and the added value and the impact, the good impact on health that the consumption of this can have, but which do not compromise the taste. So we want everything this in one same product. So very healthy, very ever friendly with sustainability, clean label, functional properties, and of course, I would say it's not, and it's more than the other things that be a tasteful product that we can tolerate at least their taste and the flavor of this product. So, to achieve this trend, food companies, food industries are now willing to reformulate their food products to include these natural sweeteners to sugar. And I can say that one of the most challenges is, of course, the price of these alternatives, and then not. I put in the same way, but also that they can be tastefully or at least tolerated more similar as possible to the white sugar. Here we have some specific attributes described and found in the literature regarding these sweeteners we have mentioned in this presentation. Of course, most or some of these attributed references need to be further studied. These are not so well studied at all. Most of these components have been we have reached an increased number of publications, but in the last few years. So to verify this, to confirm all of these attributes, it would be, of course, important to keep on researching each one of these, and of course, their inclusion and in the diet and their use that sometimes are combined with other elements, with other sweeteners. This is also a problem we have not only here but also when we talk about artificial sweeteners. It is not the carcinogenic, the potential carcinogenic effect of aspartame, but what is the combined effect when we join aspartame with acesulfame K, with sucralose, and with other elements. So this is one matter that we should take into consideration, and of course, further studies are needed to give more data on this aspect. We can conclude so that nature, of course, is an incredible source of viral compounds, including those with the sweet taste that we are discussing here, which many haven't yet been explored. Of course, more components with this sweet taste may occur in the nature that we didn't know yet. Nevertheless, it must be emphasized that being natural does not ensure their success on the market. It should also be noted that the long traditional use in some restricted societies and areas around the globe, and this despite providing some reassurance, cannot rule out the need to conduct detailed scientific studies to prove the safety of the natural compounds to be used as food additives. And sorry, one example of that is the sweeteners that we have been discussing here. The food industry needs to face the challenge of developing new products with natural functional sweeteners to continue innovating and satisfying consumers that want all in one, as I mentioned earlier. Of course, a safe product, otherwise, you can put it on the market. A tasteful product that we can enjoy it when we are consuming or when we are adding this particular sweetness to another food, and that is plenty of health benefits, health impacts, and as functional properties. So this is what the consumer demands, and of course, this is not easy, not always possible to accomplish with all these requirements, and sometimes the label of being natural, it is not the same that we go exactly to the nature and put it on the table. So as we see here, there are in some cases some extraction methods, and we need to add some other components, and the chain is quite long until we have the final product, and of course that will vary the characteristics of that product in so many aspects, and the price also, the price I forgot, but of course the price is also that the consumer wants to pay the less as possible. And this, of course, poses a very big challenge on the food industry, and also on the health professionals and all of us to find this miraculous component or components that we can recommend to our populations. So let me know what sweeteners I haven't talked here, and you have in your regions, in your country, and we are not specified here. And of course, you also use it as to sweet the drinks, the dishes, apart apart of the sugar cane and the white sugar. Thank you.
Good evening, sir.
Good afternoon, good evening.
So, how do cost and benefits of natural sweetener production compare with traditional sugar, considering health, ecological, and market criteria?
Yes, most of them are not, as we see here in some examples, some of them, the production costs are not so interesting. That is one of the great challenges, and I think you can see it when you go to the market. That these options are not are not so cheap or so interesting from that point of view for the final consumer, and the reasons are related with various aspects. One of them are not local. For example, I have maple syrup. I have agave. I didn't talk about it, but I have agave syrup. I have some options that you have not in Europe, not neither in Portugal. So the whole way it came from the natural origin, it has costs, and then the extraction methods and the processing. For example, to collect the liquors from the sap from the coconuts, then wait 8 to 12 hours to ferment. All of that, it's time consuming, not time consuming, but efforts from those ones who make this work. This will be reflected, of course, in the final price. So if you have a product that its processing of the method implying in their extraction are different compared with the other ones we have at lower prices, and a part of that they are coming from another continent. It is difficult to find here some strategy to become more interesting from the point of view of economic view. Of course, that is one of the challenges.
Yes, sir. So, one more question. What role should consumer education and labeling play in scaling sustainable and healthy sweetener use?
You are asking what can we
What role should consumer education and labeling play in scaling sustainable and healthy sweetener use?
Yes, regarding sweetener, the education is very important, and at the early stage is not to find alternative sweeteners, but to introduce the less sweetener as possible, because some foods they are already sweet. So, for example, you have in some parents that have the custom to add sugar, white sugar, but it could be another one to the fruit to make the children prefer or eat easily the fruit, because otherwise they cannot like too much, especially of course compared with other kind of sweets. So to have this role easier, the parents simply add sugar, and mainly white sugar, and of course this is not good. If there would be some actions or some education regarding to this since the early ages, of course, not be adding sugar to the fruit, because fruit has already its own sugar, so you don't eat to add and then it's the habits, the routine that those children will take to the adolescence, to the adulthood, and it's very complicated to change the habits. Here the sugar is very similar to the salt. When you are accustomed to have one amount of salt and the sugar as well, since very early ages to everything or to the most of your dishes, it's very complicated from one day to another to substitute for another thing, or you find another thing that is quite similar, but then we have some differences, and the price is very different, and this is a very important point. Not only the difference from the point of view of the taste that some of these products have, but also the price is very higher when compared to the white sugar. But it's very complicated when you are in the adulthood. When you since children you were accustomed, you learned to introduce sugar in the fruit, or to you are accustomed to intake some high amounts of sugar or salt. You can talk for both. You are talking about sweeteners, but the habits and the education regarding the salt consumption is quite similar. It's quite similar.
Yes.
These alternatives can be, of course, all of these alternatives, as we already discussed in the other session, all of them seem, since they are generally recognized as safe. Of course, that is very important. They seem better than the refined sugar, than the white sugar, because on the white sugar you have only sugar with rapid absorption sugars, with nothing else. You don't have amino acids, you don't have polyphenols and other elements with functional activities that you find here. But here you have also calories, you have also sugar, so it is not the same. You can consume this. This is wonderful at your own way, with not any concern about the amount or the quantity you will consume. No, of course, take care. It's the same with the fruits. You have calories in fruit. You have fructose in fruit. You have sugar in fruit. So, of course, you have to pay attention also to that. Um, it is very important.
Thank you, sir.
Thank you.
So good evening, sir. So like you were saying, here in India, we get raw honey, but it's almost adulterated. We get this.
Yes, that is an important issue also. And once again, first of all, the food safety and the safety regarding the product. And honey is also one problem, not only here but in other places that we can have that kind of adulteration. So it's very important to control that. Yes. Thank you for your appointment.
And so we get molasses, this blackstrap molasses.
You have also.
Yes, sir. And coconut sugar is not available in the north part, but probably it's available in the southern India. But it's not very common. Stevia is available in
And the
all.
prices are higher than the other alternatives, or not so much? The coconut sugar.
That I don't know the rates.
For example, you have coconut sugar in Portugal, but not locally, of course, and it's very very high. It's very the prices are very very higher compared with sugar, with white sugar.
So here it would be higher. In Delhi side, it would be higher because they'd have to get it.
Oh
from
yes, for sure. Yes, that we are talking about. Yes.
But stevia is available freely in the supermarkets. So, but its taste is not acceptable to many.
Yes, another problem. The taste, yes, is different.
So, my question is, when so many studies have been done right, about this risk of this sugar, like high fructose corn syrup is used a lot in US, I'm told. And you mentioned aspartame. When we know this risk, why don't we phase them out and use these alternatives? Or will it help to mix that refined sugar with these kind of alternatives? How will it?
How can we make the people use more these alternatives and not the refined sugar? There are two main reasons: prices that have the ended product and the taste. Because all of these alternatives, it will imply a different taste, and perhaps some people that is not a problem, can accept or can even enjoy. But the price is for the most. If you think in the global population, the price is quite higher, especially in the places, in the regions that you don't have local production of that, and you need to import. For example, in Portugal, we have to import this: the coconut sugar, the maple, the stevia. The stevia is also very interesting and very marketed. Maybe I can say, at least in Europe, we found very products with stevia, but when you see the price, it's not for all. At least to consuming that on a regular basis, as they usually consume sugar. We can, of course, one time we can buy some product with stevia or that alternative, but not to substitute as on frequently consumed, because the price is quite different. So, for the population, the reason, I believe the main reason, and of course they are not so access in the markets as the white sugar. White sugar, you have it in every place, and some of these alternatives only on some specific shops, some specific markets, because the price is high and nobody not every shop wants to have it because they know that they will not sell. So only on some particular markets, shops you can find. So the two main reasons I would say price and taste.
Thank you, sir.
Good evening, sir.
Good evening.
So, sir, my question is, can this erythritol be used in the production of bakery products?
Yes, if it will be accepted, erythritol is also very strong, a very different taste. But from the point of view of theoric point of view, yes, it can be used. The other thing is if then the final product will be accepted by the consumer. That is the that will be always unrelated, not only specific to erythritol, but all of this. It's like the stevia, the use of stevia. It can be used, but the flavor it will be quite different if you use stevia, erythritol, or white sugar.
Okay. So, sir, can it affect the texture and shelf life of this bakery product?
Yes, you can have them also from the texture. Yes. The organoleptic characteristics may vary, and according the sweetener you use may vary. And the same we have if you make the same experience with the artificial ones. You can try to make a cake without sugar cane, and use it some artificial sweetener, for example, the aspartame. We will see the flavor, the taste, very different, very different.
Thank you, sir.
Good evening, sir.
Good evening.
So my question is that how uh, how natural sweeteners can interact with gut microbe?
It's a very interesting question, and also not only the natural. We can talk about artificial sweeteners, and that is a very hot topic, an emergent issue of research. And for example, one of the concerns first regarding the artificial sweeteners there is they are considered as safe in some limits, in some amounts, but some researchers are studying the impact that those sweeteners can have on the metabolism of the microbiota we have in our gut, and then of course indirectly that if the homeostasis of that microbiota is affected, of course that can affect our health, our gut health, and our health. The same with this. The same with this, of course, need to be studied, in particular, in case by case. And for example, talmatine is studied, and that can have some affections. And there is no much evidence on that, but there is effect. We know that it will affect, of course, the gut microbiota and consequently our health. And this is a very interesting topic to study. Yes.
Thank you, sir.
Good afternoon, sir.
Good afternoon.
So, like, I don't remember the exact name, but one of your slide, like in table, you were mentioning, I think, thaumatin or glyceric acid, like it's reducing sugar after meal. So, postprandial sugar, it's reducing. It helps to reduce it. So, how, can you explain, like, it's a natural sweetener. So, how does it does?
Yes, but it's a sweetener. It's called sweetener because it has the power of make when you add to that food sweetener. But the difference between these sweeteners and the refined sugar, the perhaps the most non-sweetener we are accustomed to, is they have another elements, and these elements can help in that way. And that is an example of glyceric acid, glycerin, that have some elements, bioactive components that can make the digestion slower and can act also as that. But of course, this we need to study in which kind of consumption on a regular basis, in which amounts. All of this is not so well and so specified in the literature. They have these components, they have these bioactivities, the white sugar doesn't have. So this can be interesting, but at which point? the quantities that we will need to add to the food and we will intake are sufficient to see all of this. Because also when I present the table with all properties that say anti-carcinogenic, anti-mutagenic, this need to be studied. We can only just see the macros, the food macros and the components we find there and see this is wonderful for this, for another. No, but in which amounts you will intake this, you will eat this. And then, if included in the diet, you will not consume this alone, and with the other components. So all of these need to be studied.
Okay. Good afternoon, sir. Sir, how do natural sugar sweetener affect the metabolism in compared to refined sugar?
Exactly the same answer I gave to your colleague. The reason is exactly the same.
Okay, sir.
Exactly the same.
Actually, I did not listen.
Nothing to add.
Can you explain once more?
Ask your colleague to explain.
Okay, sir.
How
Thank you.
can? No, no, please ask. I want to know if she
Like
like make this a bit more interactive.
first of all, so that it has not been studied, and also like to know that what metabolic process is going on, we need a case study and what and all internal like due to which process or like maybe it is like lowering sudden glucose spike of other food which has been like eaten by the person, maybe like that.
Yes, we have to see the components that are in that specific natural sweetener we are talking about, and then not only the components, we have to see the interaction of those components in the organism. In this case, in our organism, in our metabolism, and included in not alone, but joining with the other elements of the diet, and which quantity of natural sweetener we are talking about. It is not only to see they have polyphenols, phytochemicals. No, but in that amount with the other components, this will really have that carcinogenic effect. We don't know. I don't know the quantities, and of course, we don't know if it is feasible for the people to consume it because with these prices, populations can't consume. So it is impossible. It is not worthing to being studying something that population can't buy. We are studying that for what? If we can't find a way to make it more accessible, more available to the population. That is also so important, so more important than studying all the bioactivities, all the properties of the food. If I have sugar cane 1 kg for less than €1, if I have 200 grams of agave syrup for €10, I can say stop consuming white sugar and start to consume agave syrup or maple syrup or coconut sugar or what else. Wasting time on studying the properties and money. Because when you talk about alternative, it must be a suitable alternative, a feasible alternative. So the price matters. We must think on production methods and where we will collect those sources, alternative sources, to recommend them to the populations. I can recommend the populations to consume something that they can't access. Once again, the availability and access. The product must be available, but not access to all the people. And I want to talk, and I want to point to the general population. But of course, that will depend each source, each natural sweetener, and it will depend of the region. Because in some regions, some sweeteners, some product can be high cost, but not in the others. We have to see all that all those aspects. Yes, thank you.
Sir, why solvent-free extraction is vital for sustainability?
Which extraction?
Solvent-free
Yes,
extraction method.
Yes, of
is
course.
vital for
And
sustainability.
of course, for example, when we are talking about some of these specific sweeteners that you need to add a lot of chemicals, and the extraction process takes a longer time, you have this and sustainability are not in are not related. So this is one example of why when we are talking about natural products, they can make the direct relation. It is natural, so it is very sustainable. So I think here the example of this cannot be true in some cases. So if we add that, we need to add all of that solvents to, and then to make the separation, the purification, all of that. How long we will take, and how is the way we need to do to until we have the final product. Of course, the source is natural, but what we need to do, and time consuming and money and everything to arrive to the ended product. So where is here the sustainability? And if I don't have that product in my region, in my continent, and I have to buy it from the other part of the world. So if we analyze this, we can have a natural natural product, natural food product, but of course sustainability can be compromised, and that is one important thing. Not to be natural, that is for sure a sustainable one. Thank you for your point. Yes, thank you.
So thank you so much, Dr. Apsu, for that enlightening and detailed presentation. Your talk beautifully highlighted how natural sweeteners can contribute to a healthier and more sustainable food system when produced safely and responsibly. You took us through the fascinating process behind the production of sweeteners, natural sweeteners basically, and how biotechnology is helping when produced. Uh, these processes are more efficient and eco-friendly. It was particularly enlightful to understand that while those compounds come from the natural sources, their safety, purity, and scientific validation remain equally important. Your emphasis on the needs for continued innovation in the food industry to develop natural functional sweeteners truly tied the session together. Thank you once again, sir. So, as we come to the close of this day 7 of the GAN program, it's wonderful to take back one another enriching day of learning exchange. Today truly showcased how innovation and tradition come together to shape the sustainable food future. For exploring bioprinting and futuristic food production technologies, to discovering the power of millets for nutrition, resilience, and understanding the potential of natural sweeteners as healthier and eco friendly alternatives. The day offered a perfect balance of science, sustainability, and real world relevance. Each session encouraged us to think beyond the ordinary, to imagine the food systems that are technologically advanced, nutritionally rich, and environmentally responsible. The discussions are also highlighted the importance of the collaborations across disciplines to bring about meaningful changes in the food and nutrition landscape. I sincerely thank all our distinguished speakers for their enlightening sessions and also participants for their enthusiastic engagement throughout the day. Before we conclude, a gentle reminder for you guys, please be prepared for the GAN assessment scheduled maybe tomorrow or day after tomorrow. It will be help all that we have learned during the intensive and inspiring week. With that, we officially conclude day 7 of the GAN course. Thank you all for your active participation and see you tomorrow for the assessment and another fulfilling day of learning. Have a pleasant evening. Thank you so much, guys.